last but not least, I need a video for the chapter 3 warm-ups. I did not have one before, so here's another one. I'm in the same spot that I was before, and I just can't get out of that shadow. That's okay. That's just how it is in this room. All right, so this has a calculator portion and a non-calculator portion. Okay. All right, so here we go. At x equals 1, the function f of x equals 4x squared minus 1 when x is less than 1, and 8x minus 1 when x is greater than or equal to 1 is, we got to figure out if it's continuous but not differentiable, differentiable but not continuous, both continuous and differentiable, or neither continuous nor differentiable. I could already tell you what it's not. If it's differentiable, it has to be continuous. So there's no way it could be differentiable and not continuous. So this is automatically wrong. I know it's not B. So at least that. Okay. Well, to check for continuity, it's just like all the other ones we've been doing. You have to set the two pieces of the piecewise function equal to each other. So 4x squared minus 1 equals 8x minus 1. Remember, the value of x in question is an x value of 1. So you need to plug in the 1. So 4 times 1 squared minus 1. Is that going to equal 8 times 1 minus 1? Well, 1 squared is 1. 1 times 4 is 4. 4 minus 3, or 4 minus 1 is 3. My bad. 8 times 1 is 8. 8 minus 1 is 7. Uh-oh. Those are not equal. So this is not continuous. Okay. Well, if it's not continuous, there's no way in the world it's going to be differentiable because it's not continuous. It has to be continuous in order to be able to take a derivative. So it is not A, it is not C, it is neither continuous nor differentiable. So D was the correct answer. Number 2, what is an equation of the tangent line to the graph of y equals the sine of 2x at x equals pi over 2. Anytime you're told to look for the equation of a tangent line, you need to take a derivative. So first of all, we have the x value here. So you know when you write an equation of a tangent line, we usually use t of x. You're going to need your slope times x minus pi over 2 plus you need your y value. Okay, we've got the x value, it's pi over 2. We need the y value, so let's find that first. To find it, you're going to substitute that pi over 2 in for the x there, and you're going to solve for y. So y equals the sine of 2 times pi over 2. Well, the 2's are going to cancel, so it's just the sine of pi. Well, at pi, that coordinate is -1, 0. The -1 is the cosine, the 0 is the sine, so this is equal to 0. So it's just a plus 0. Okay. So you might already be able to tell which two options in the multiple choice it is not, but that's okay if you don't, because we're going to keep going. All right, now I need to take the derivative of y. Well, I have to use chain rule because I have a function within a function. So I have to take the derivative of the inside. The derivative of 2x is a 2 times the derivative overall, where the derivative of sine is cosine, and then you keep the same insides. So 2 times cosine of 2x. Okay, well now I need to plug in the x value in question. So that is 2 cosine of 2 times pi over 2. And those 2's cancel again. And we already know the cosine of pi is -1. 2 times a -1 is -2. That is the slope. Okay. So this is our equation of the tangent line. So it's just -2 times x minus pi over 2 because you don't really need that plus 0 there. So I can already tell that it's B. B is it. Number 3, which you guys saw me do in my graphing calculator video. If f of x is the function given by f of x equals 2e to the 4x plus 3, at what value of x is the slope of the tangent line equal to 1? So they're trying to say, when is the derivative equal to 1? At what x value is this? What x value will do this? Okay, well, that means I got to take the derivative of f of x. So f of x equals 2e to the 4x plus 3. So when I take its derivative, you could do it by hand, but because this is a calculator portion of the test, or well, in our warm-up, you get to use a graphing calculator. So when you find this derivative in your calculator, you're going to hit Math 8, and then you're going to get d dx, and then you need to plug in your function, but you should have already typed it into the y1 because it's going to take the derivative for you at x equals x. But because we want to find when the derivative is 1, that means I want to move that 1 to the other side by subtracting it. So I need the derivative minus 1 so that I can see where the graph crosses the x-axis at, hence finding the 0, and that will be the solution. So I need to put a minus 1 on the end. Now I could do this by hand, but I've done a bunch of questions already doing it by hand, so I'm not going to do this one by hand. I'm just going to do it strictly in the calculator. So here I go. Y equals, let me clear out all this stuff and start fresh. So the original function is 2e to the 4x power, arrow down, plus 3. And arrow down to the y2. Now I need to hit Math 8, d dx, alpha trace, y1, x equals x, but I need it to be, what was it, minus 1. And I don't want both of these graphed. So I want to unhighlight that first one. I just want to see the derivative graph, and I want to see where it's crossing the x-axis at. So I'm going to hit graph. Thinking, thinking, thinking. Almost done. I hope. There it is. Okay. All right. So now I want to hit trace, and I'm looking for my y value. So I see it's at a 3.8. I want it to be as small as possible. There it is. I'm just looking for my cursor. Okay. So let me see. Yep. That is the very last negative number. So that's where I want to be. So that is going to be my left bound. So I want to hit second, calculate. I want to find the 0, so hit 2. I already have my left bound, so I'm going to hit enter. Scroll to the right so that I get to the next number. It should be positive. That's my right bound. Hit enter. And then it's going to guess the 0 that's in between that left and right bound. So the 0 is negative 0.5198, so negative 0.52. So now I have an old copy of the warm-ups. You guys have the newer copy. So for A, it said 0.52. For B, it said negative 0.52, which is the answer. For C, it said negative 1.52. And for D, it said 1.52. So obviously B is the correct answer. So there you go. All right. Number 4. Which of the following values of x is g prime of x undefined? Well, we don't really need a calculator for this part because we're looking at this graph. So for the derivative to be undefined, we're looking for places where that could happen. So looking at this graph and looking at what we've got here, let's look at x equals negative 2. Well, at x equals negative 2, we can have a horizontal tangent. That's totally fine. That just means the slope is 0. So that isn't undefined, so that's not an option. At negative 1, though, it is undefined because we have a jump here. So this one, it is undefined at x equals negative 1. At x equals 3, that would be right here. Well, that's a corner, or you could argue it's a cusp. Either way, corner or cusp, it is undefined right there. So that one is also undefined at x equals 3. So the places where g prime of x is undefined is just 2 and 3. So that would be D. Okay. And then number 5 gets into the non-calculator portion, but really only one of these questions you really needed a calculator for. Everything else was by hand anyway, but the rest of this is going to be strictly by hand. So I could turn my calculator off and put that away. All right, so number 5, it says if the line negative 2x plus 6y equals 25 is an equation of the normal line to the graph of f of x at the point 1, 3, then what is the value of f prime of 1? So basically, this is the normal line, or n of x. It is negative 2x plus 6y equals 25. What I can do is if I can find the slope of this line, I know the slope of the tangent line is the opposite reciprocal of the normal line. Well, the slope of the tangent line is the derivative of the graph at that x value of 1, right? So I just need to find the slope of this, find its opposite reciprocal, and then I have the answer, okay? So I need to solve for y. I got to put this in standard form. Y equals mx plus b. So I've got to move that negative 2x over, so I've got to add it over. So that would be 6y equals 2x plus 25, because when you add it over, it's going to be a positive 2x. Then we need to divide everything by 6. So we'll get y equals 2 over 6 reduces to 1/3 x plus 25 over 6. Don't worry about all the fractions. The only one you should care about is this one, because that is the slope of the normal line. Well, you need to take that slope and you need to use it to find the slope of the tangent line, which is the opposite reciprocal of this number. The opposite reciprocal of 1/3 is a negative 3 over 1, or negative 3. So negative 3 is the answer. So the answer is D. Okay. All right, number 6, if h of x, these are my favorite, equals f of g of x, find h prime of a if the following differential values are true. All right, so we need to take the derivative of this function. So I'm going to start with h of x equals f of g of x. I'm not going to plug in anything yet until we take the derivative. So step number 1, we have to use the chain rule because we have a function within a function. So the derivative of g of x, so h prime of x equals, the derivative of the inside would be g prime of x, the derivative of g, times the derivative overall, so f prime of, and you always keep the inside the same. Okay, so that's the derivative. So now I'm finding the derivative at an a value. So h prime of a. So now I'm going to plug in a's for all the x's. So g prime of a times f prime of g of a. And we're going to be substituting things as we go from this data. Okay, so g prime of a. G prime of a is equal to c. So I'm going to replace g prime of a with a c times f prime of g of a equals m. Okay. Well, now I need to replace f prime of m with something. F prime of m equals 3. So this is c times 3. C times 3 is a 3c. So 3c is the answer. So the answer is C. Was that all? Nope, 2 more. Number 7. Which statements are true about the function g of x graphed below? So let's see here. Oh, we crossed out this one, so that must have been a typo. So we're at g prime of 3. So here's our graph. This is g of x. This is the original function. Remember, a prime means a derivative, which means the slope. So it's saying the slope when x is 3 is a 1. So where is x at 3? That's right here. Here's my x value of 3. So is the slope a 1? So if I were to look at from this point to this point, because that would be easy, it looks like I'd be up 2 units over 2 units, rise over 1. 2 divided by 2 is 1. So yeah, that's true. At an x value of 3, the slope is a 1. That's true. Okay, let's look at the second statement. g prime of x, so the derivative, the slope is greater than 0, so the slope is positive on these two intervals. Well, let's see. From -3 to -2, that's this interval right here, this part of the graph. That is a positive slope from left to right. That's true. Check. From 1 to infinity, well, it's slanted a little bit, so positive, but then it's going to negative. It has a negative slope over here. So it's not going to be a positive slope the whole way. It stops at a 4. So this is false. So because part of it is false, the whole thing is false. So it's not going to be Roman numeral 2. Roman numeral 3, g of x is continuous but not differentiable at x equals 0. Well, 0 is right here, and this is like a horizontal line. There's nothing wrong with a horizontal line. There would be something wrong right here at this corner, or at this corner, or at this corner, or at this corner, but it's fine. So, or even at this corner, even though it's a slight corner. But at 0, it's totally fine. So that's false. So 1 is the only one that's true. But number 8, the last one. Okay, so it says if h of x equals the square root of g of x, g of 2 equals 8, g prime of 2 equals -4, what is the value of h prime of 2? So it's one of these again. So I'm going to start by writing it down. H of x equals, but instead of the square root of g of x, I'm going to put g of x to the 1/2 power, because that's going to be easier to take the derivative of. And now let's take the derivative. So h prime of x equals, well, we have to use chain rule because I have a g of x function inside of a square root function. So you have to take the derivative of the inside. So the derivative of g of x times the derivative overall, you got to bring down that 1/2. And then that would be of g of x to 1/2 minus 1 is a -1/2 power now. Okay, so now to clean this up a little bit, this g of x to the -1/2 power, we got to drop it like it's hot. There's already a 2 in the denominator, but this g prime of x is going to be in the numerator. So let's rewrite this. So g prime of x is the only thing that's going to be in the numerator. We have a 2 in the denominator, and we can put the square root back on of g of x. Okay, now let's plug in the value of 2. So h prime of 2 equals g prime of 2 over 2 square root g of 2. All right, well, let's replace some things. G prime of 2 equals -4. So that's a -4 up there. Over 2 times the square root of g of 2. Well, g of 2 is equal to 8. So that's a square root of 8. All right, well, I can't really do anything with the square root of 8 because it's not a perfect square, but 2 goes into 4 twice. So that is a -2 over the square root of 8, and that's as low as I can go. That is the answer. So the answer is D, and that's it. Thank God, because my phone's out of battery. All right, good luck, you guys.